First thing I want to do is I want to start in that first quadrant again. Yeah, you should take out your circle. It should be inside that book, right? So I just want to work through this again. Okay, one of the things that students find difficult to understand is what they're actually asking for when it comes to the questions. And in this case, they're saying, okay, well, what's the exact value of the sine of 30 degrees? So what is it they're actually asking? Well, if they're asking you and they specifically say, okay, well, what is the actual exact value of sine 30 degrees? I'm asking you about the ratio. So the ratio of the side opposite to the hypotenuse. Now, in this case right now, if I write out my coordinates are root 3 over 2 and 1/2 for this, correct? Therefore, the sine of 30 degrees is what? 1/2. That means that even though we said the radius of this circle is 1, when you compare the ratio of this side to this side, I'm going to get a ratio of 1/2. So that means that this would be 1/2 right here. And this would be root 3 over 2. Because I already stated that it's a unit circle, therefore my ratio is 1. Okay? But when I take root 3 squared and I add it to 1/2 squared, using Pythagoras' theorem, I end up with it equaling to 1. So it doesn't matter what coordinates I use. When I add my ratios together, they should equal 1 as my overall value. So take a look at page 121. I'm going to show you the way the book does it, and then I'm going to show you the way that I suggest you do it. Because the way I'm going to do it is the same way that I would have taught you this in grade 11. So it says point A is negative 4 over 5 and y. And it does tell you it's in quadrant 2. Okay. So what this says is this. Is on my unit circle, if I take any coordinate x and y in the unit circle, that means that the cos of the angle, cos of that angle is this, and the sine of the angle is that. You agree with me? That's what we've learned so far, correct? So instead of x, y, I know that it's the ratio of the cos theta, meaning the adjacent over the hypotenuse, and the sine theta. And that it's equal to 1. Agreed? Well, this distance right here is x and this is y, because of the x and y. Using Pythagoras' theorem, I get x squared plus y squared is equal to 1 squared. Right? So I could go cos squared theta plus sine squared theta, and that's going to equal to 1 squared. Right? So that means that if I take any coordinate on this circle, I can use this Pythagoras' theorem, x squared plus y squared equals 1 squared, to find out what the other value is. So they give us the coordinate negative 4 over 5 and y. So using that same thought process, I go minus 4 over 5 squared plus y squared is equal to 1 squared. Right? 16 over 25 plus y squared is equal to 1. Y squared is equal to 1 minus 16 over 25. Y squared is equal to 9 over 25. What's that?
It'd be plus. Or is it squared so it gets rid of negative? Yeah.
Yeah, negative 4 over 5 squared is that.
Yeah.
And then I subtract it. Okay? Now, take the square root. And what do we know about the square root? When I take the square root of 9 over 25, what is it? 3 over 5? But what do I have to remember when I take the square root of anything? It could be either a plus or a negative. So how do I determine, is it a plus 3 over 5 or a minus 3 over 5? How do I determine which one it is? Which quadrant it's in? And in quadrant 2 is sign positive or negative? Positive. So my coordinate is negative 4 over 5 and 3 over 5. That's the coordinate in quadrant 2.
Excuse me for the
Okay.
interruption. Jaden Case to the office for a phone call, please. Jaden Case.
It equal to 1.
Is the radius 1 on the unit circle?
Yeah, all these questions have to do with unit circle, we're not gonna get other circles.
Okay? Now, I'm going to show you a much simpler way of doing this question the same way I would have showed you in grade 11 last year. And it makes everything else easier as we go along because we're going to get some more difficult questions when it gets into using identities and finding half angles and different angles. So I'm going to show you the method that I would suggest you use. So let's review the question again. So the question says that I have point A on the unit circle, in which that's minus 4 over 5 and y, and it's in quadrant 2. So here's what I'd like you to do. I would like you to first off make yourself a triangle in quadrant 2. And the angle is always made with the x-axis. Alright, what do I know about that x? Is it the cos value or the sine value? It's cos. So the cos of that angle theta. Cos of angle theta is equal to negative 4 over 5. So what do I want to find? I want to find out what my sine ratio is. Okay, that's my intended goal. Cos squared plus sine squared equals 1. But there's another way I can do this. Cos is adjacent over hypotenuse, agreed? That means that this is negative 4 over 5. Right? What's that then? What's the measure of that side? No, I just want the measure of this side. How do you get it? 25 minus 16 is 9. Square root of 9 is 3. Okay, what's the sine of theta now? And I'm done. That's the easiest way to do these questions. Okay? I'm going to show you a question from last year that you did. And I'll show you how we did it the exact same way. Okay? And that was this. You have point A. Point A, or coordinate A, is at negative 6 and 8. So, you had to put it on your grid, somewhere up here. Draw a line through it. Label it. X is negative 6. That's 8. There's theta. And then I asked you, find the 3 trig ratios. So find cos theta, sine theta, tan theta. Okay? Well, what do I need in order to get those ratios? What do I got to find first? The hypotenuse. 6 squared is 36. 8 squared is 64. 64 and 36 make 100. Square root of 100 is 10. So what are my trig ratios? What's the cos of theta?
Negative 6 over 10.
Negative 6 over 10. What's the sine of theta?
8 over 10.
8 over 10. And what was the tan of theta?
8 over negative 6.
over negative 6. That's what we did last year. That's what we did last year. It's done the exact same way. The only difference now is that they're giving you the ratio as cos theta and sine theta as your coordinate. Like that. It's the only difference. We did it the exact same way. Okay? This is easy right now, doing it this way. What's going to happen is you're going to get two sets of ratios, and you're going to have another triangle somewhere over here, and then you have to put these all together, all these ratios, and we have to use them to find different angles. That's where we're going. It's not complicated as long as you can do that here today. Alright? So let's look at B, and let's do it the same way I just did. So it says point B is 3 over 10 and y in quadrant 4. So first thing I'm going to do, draw my triangle in the correct quadrant and label. And by labeling I mean put theta with the x-axis at all times. Okay, so what's the cos ratio? 3 over 10. Okay, let's find the other side. So 100 minus 9, square root of 91. Leave it at square root 91. Do not, under any circumstances, put that into your calculator and solve it. You can break it down. If there's a perfect square that goes into it, break it down. But do not put decimals in there. Under any circumstances, do not put decimals in there. Because the question says, what is the exact value? If you put a decimal, you have a rounded number. That is no longer exact. Leave it as square root. Okay? And so what we're looking for y. Okay? First of all, I should have put a negative there, correct? Y is negative in that quadrant. So what is the sine ratio of theta now? Or y, what is it? Negative root 91 over 10. And I've done that question. I'm done question B. Okay? It's not hard. I understand we can get confused by some things, but it's not really that hard. As long as you draw your triangle, you should be able to do the right angle trig. You don't even have to solve anything. It's not asking you what the angle is. It's just asking you what is the ratio to get the angle. Is it cos 3 over 10? Or is it sine negative 91 over 91 over 10? Or is it tan negative 91 over 3? That's all you have to put as your answer for it. Okay? Have a look at working example on 122. Thank you. Determine the coordinates. Okay, so there's two ways they can ask this for you. Determine the exact values or determine the coordinates. Those both mean the same thing. Determine the coordinates of all points in the unit circle for which the reference angle is pi over 6. The reference angle is pi over 6. So what do I want? I want all of the coordinates on the circle in which the reference angle is pi over 6. So my reference angle is always found in the first quadrant, pi over 6. What are the coordinates for pi over 6? What's the cos of pi over 6? Well, sometimes it's easier to ask myself, what is pi over 6 in degrees? 30. So what's the cos of 30 degrees? Root 3 over 2. What's the sine of 30 degrees? A half. Okay, so there's the first quadrant. The second quadrant is over here. What are the coordinates? This again is pi over 6. What are my coordinates now? And values don't change. What's changing on them? What is it down here? Yeah? Can we do that? Okay, so what if I said to you, all right, don't have to write this down. But what if I said to you, okay, I want all the coordinates for pi over 3s, where reference angle is pi over 3. So what am I talking about? Up here, reference angle, pi over 3. What's my coordinates?
This is your 60 degree.
Yeah? Come on, what's my coordinates? You shouldn't have to look back at it. What are my coordinates? We're still talking the 30, 60, 90 triangle, right? So what are my coordinates?
1/2 and root 3 over 2.
I'm still talking the same values here, aren't I? It's still a 30, 60, 90 triangle. All I'm doing is changing what the angle, by what perspective am I looking at the angle? In this one I'm looking at the angle as if it's 30 degrees. In this one I'm looking at it as if it's 60. So what switches? Just these two. They just switch. Okay, so now up here, what are the coordinates up here then? -1/2 and root 3 over 2. How about down here? What is it?
-1/2 and
Yeah. Down here?
1/2
Like that. When you're talking about all the pi over 6s and the pi over 3s, it's the same triangle. I've already listed almost everything I needed to off that whole triangle. What's the only thing that I'm missing right now? 2 things, in fact. The 45s. Right? And then I'm also missing the quadrantals. The 0, 90, 180, and 270. But just like that, in a matter of seconds, I was able to do all my pi over 6s just like that. Because these ratios are all the same. It's just what perspective are you looking at it? And what's your reference angle? Is your reference angle 30 or is your reference angle 60? So every time you do these questions, that's what you ask yourself. Is my reference angle 30 or is my reference angle 60? Fair enough? It's not, like I said, it's real easy stuff. You do have a little bit of work to do in memorizing, but that's the way it goes. Look at page 125, please. When it's asking you in this form, so I need you to point P theta is a point at which the terminal arm of the angle theta is in standard position, intersects the unit circle. Determine the exact coordinates. So I'm looking for the exact coordinates at the following. So when you see this, I'm looking for the exact coordinates at pi over 2. So what am I looking for? What is the cos at pi over 2? And what is the sine at pi over 2? Okay? That's what it's asking you when it puts it in that form. Alright? Where's pi over 2 in a unit circle? 90. What's the coordinates at 90? 0, 1. There's your answer. Done. That's my answer. What's the cos of 90 degrees? What's the cos of 90 degrees? 0. What's the sine of 90 degrees? 1. I know you guys get tired at this time of day, but it's like pulling teeth to get questions and answers out of you guys. I can't make it any more interesting if you're just going to sit there like bumps on a log. You need to help yourselves. And you need to help me up here. Because I may as well just give you the textbook and say, okay, go work on your own. And do it as an independent study. If you're not going to help up here, then I'm not much use to you. You guys need to work with me here. Alright?
So when we're doing this, for the cos, can we just do cos, like for B, cos 2 pi, and just put it in a calculator?
Absolutely not. You do not use your calculator for any of this. None of it. Okay? Plus your calculator is not going to give it to you correctly, because you'd have to change it to radians. So there is a moment where we do use our calculators a little bit. But right now, this whole thing is just about the unit circle. Take a look at page 128. As soon as I'm done here, that's what you're doing. As soon as I'm done, you go to page 128 and you fill it in. Okay? Are there any questions today?
Yeah.
Go ahead.
Question 5A and 117. Based on the last one, the 0 plus 2 times the bases.
So 0, so you take, no, it's not 0, it's your angle. So
Okay.
255 plus 720. Bless you.
Okay, but since our domain has to be within the
Yeah,
circle,
so then, so
it
that,
just stays.
yeah, so you can't make an answer for that.
Okay.
It's outside your domain.
Alright, and then also, on page 116C, how do I,
3 or 4.
3, sorry,
So minus 2 pi over 9.
yeah,
And what's it asking you to do?
it wants it in degrees,
In degrees?
yeah.
What's the ratio that I gotta multiply if I want degrees?
Pi over 180 or 180
I want degrees. So what goes on top?
degrees.
Cancel. Gives me a 20. There's your answer.
So we can
Right? You have other questions on that?
Okay, so then for 3B, that's the same, then I'll just do the 180.
Yes.
For that same question with their -40, when you're drawing it on like the this circle right
Yeah.
here, do you go like from the like down?
Yes.
Okay.
Yeah.
And then go all the
Negative.
way up to where 40 would be like in the first
No,
quadrant?
no.
Or you just go 40 degrees?
Right there.
Okay.
Okay. One thing I haven't given you that we need for your exam, this is given on your formula sheet. Look at page 117, question 6. Determine the arc length subtended by each central angle. Give the angle to the nearest unit. Arc length is found by taking the central angle, theta, in radian measure, and timesing it by the radius of the circle. So, what I'm looking at is this. Remember, radian measure talks about that distance around, okay, based on the angle it's given to you. So, to actually calculate what arc length is, S, that is this distance right here. Now, I said it was radian measure. Well, that's not entirely true. That distance can be found using the radian measure and multiplying it by the radius, being r here. That's what we call arc length. So if it gives it to you as a radius of 20 and a central angle of 2 pi over 3, then that arc length is 40 pi over 3 centimeters. You can leave your answer like that. This is new to you. You have not seen this yet.
Do we get that?
Yes, I just said that. Not in your ears is the problem. Okay? It's the first equation on your formula sheet, actually. Very first equation. Okay?
So central angle and this part?
Okay, look at B on the next part. Oh, sorry. Okay, let's go back. I'll answer your question first. 2 pi over 3 is actually up here. So, I'm looking for this distance right here.
Oh, okay. And that's, the angle would be,
This angle right here is 2 pi over 3.
okay.
Okay? Yeah, that's fine. So I'm looking for that distance from here to here with a radius of 20. So that distance is 40 pi over 3. Okay, so if you look at B, what's the first thing that you notice?
It's in millimeters.
Okay, what's the second thing you notice?
It's in degrees.
It's in degrees. You have to change that to radians and then do the question. Okay? All right. What's the first thing you're going to do right now? Page 128. Complete that, please.